Callan Bentley. Welcome back for another Smart Figure. And after watching this video, you should be able to describe the changes that take place along the course of a stream from its headwaters to its mouth. Now, this is a look at a stream that's fairly close to its headwaters, and you can tell that it's pretty close to its headwaters because you can see mountains in the background and lots of really big particles of sediment and rushing water that has a very steep gradient. So all of these are sort of symptoms of what we would expect to see near the very top end of a stream. So the headwaters, like we were just looking at, are over here on the left of this picture, and you can see little tributaries merging in this region of headwaters, raging mountain streams like the one we just looked at that merge into larger trunk streams. The photo that we just looked at is sort of the zone of sediment production or erosion, where those mountains are actively being eroded, dumping sediment into the stream. There'll be another zone further downstream, which is the zone of transportation. That's where you have a proper trunk stream. That trunk stream may show meandering, and then eventually it gets down to where it finally ends up in the sea or whatever its final destination is. And that, of course, is where the sediment gets dumped. It's the zone of deposition, and we refer to that as the mouth of the stream. Here's an example from real life. This is looking west at the Sierra Nevada of California with the Great Central Valley in the foreground and the Owens Valley way off there in the distance here in the background. And you can see that there are several different little tributaries here that come together and they merge and then they flow down as the Kings River through the Great Central Valley of California. Now, if you plot the elevation of the Kings River from its head to its mouth, you get the graph shown up here at the top. And you can see that the gradient is much steeper up near the headwaters, and then it basically flattens out a bit as it comes into the foothills region here of the Sierra Nevada, and then it gets very flat indeed, with one exception, all the way to its mouth. So there's a little nick point there along the stream's gradient. But other than that, it's a pretty smooth drop. So if we wanted to summarize the trends that we see from the headwaters to the mouth, we can plot that on this graph. So essentially what we're going to show here is increasing in different trends on the vertical axis, and then distance from the headwaters to the mouth on the horizontal axis. The first thing we want to take a look at is the channel slope or gradient, and that was what we just examined with the Sierra Nevada Great Central Valley example. Basically, it's steeper uphill near the headwaters and it gets more gentle towards the mouth. A second factor is channel roughness. The channels are much rougher up towards the headwaters, and they tend to get smoothed out and abraded to smooth channels with low levels of roughness. Another variable we might consider is how fast the stream is flowing, its flow velocity. Near the headwaters, it's actually relatively low flow velocity, and near the mouth, it gets to be higher. A fourth variable we might consider is how big the channel is, how wide it is, and how deep it is. What's its cross-sectional area? And obviously, up near the headwaters, you just have tiny little rills which have almost no channel size at all. And when you get down towards the mouth, that's where the stream is most well developed, and so you have a large channel size. What about the total volume of water that be passing through the channel? What would your guess be as to discharge? Is discharge going to be higher near the headwaters or higher near the mouth of the river? Well, hopefully you said that it'd be higher near the mouth of the river, and indeed that's true, because the further down you go on a river, it's getting more and more water from its tributaries. It increases towards the mouth. Nicely done. Thanks very much for your attention. This has been another Smart Figure.